First of all, good afternoon to one and all. This is Dr. Surya Prakash, Assistant Professor, Department of Civil Engineering, KLD Muttupi University. So I welcome all the participants and dignitaries to a two-day workshop on advances in sustainable construction materials. First of all, I would like to call upon or introduce a chair for this parallel session. Dr. B. Sharachandra Kumar, Professor, Department of Civil Engineering, KHIT, Guntur. Welcome, sir. Welcome to a two-day international workshop. So, Dr. B. Sharachandra Kumar is working as a professor in Department of Civil Engineering at Kallam Arnad Reddy Institute of Technology, Guntur. He is having 10 years of research and teaching experience. He is a member of Institute of Engineers India and Indian Society of Technical Education. He completed his bachelor's degree from GMR Institute of Technology, Rajam, in the field of civil engineering. Later, he finished master's and doctor of philosophy from KL University in structural engineering. He attended multiple FDPs as a speaker, and his research interests are geopolymer concrete green buildings. He has published 60 research papers in international as well as national referred journals and 22 articles in the conferences so far. He published even patent on geopolymer concrete. He's actively organized and actively participating in national and international conferences, FDPs, and guest lectures. He has guided several UG and PG students as well. Right now, he's acting as a reviewer for reputed national and international journals. He was recipient of Inspirational Young Faculty Award by Amravati Research Academy, Hyderabad for the year 2019. Once again, I welcome you, sir, for this 2 days international workshop.
Thank you,
sir. And also, I would like to introduce Dr. Hanuma, Assistant Professor, Velagapudi Ramakrishna Siddharth Engineering College, as a co-chair for this parallel session for two-day international conference on advances in sustainable construction materials. Dr. Hanuma is working as an assistant professor in VR Siddhartha Engineering College. He completed his doctoral studies from NIT Warangal on a topic, strength and deformation of graded glass fiber reinforced concrete under uniaxial stress. He received an outstanding concrete paper of Andhra Pradesh for ICA Vijayawada Center and Ultratech Award 2020. I received Institute Teaching Assistantship as a PhD scholar at NIT Warangal from Ministry of Human Resource Development from December 2014 to December 2018. He has received Institute Teaching Assistantship at NIT Surathkal from MHRD during his MTech tenure from July 2010 to July 2012. So he received Best Teacher Award from Vignan's Foundation for Science in Technology and Research, Muttupi University. And also he published more than 20 paper publications, and also he participated or he actively involved in many sponsored research projects. So once again, maybe he will be join us in the meantime. Sir, Dr. Sharachandra sir, can we start?
Yes, sir.
Yeah. So I would like to call upon our first speaker, Srikanth Bomisetti. Are you ready?
Yes, sir.
Srikanth Bomisetti. Can I have your ID number? I mean, what is your ID number so that, yeah.
19, sir.
Yeah. You can start your presentation. And one more thing, I would like to intimate to all the participants that don't spend too much time on literature and all those things. First, introduce your topic, go to methodology, okay, and finally your results and conclusions. Is it okay, sir? Sharachandra sir?
Yes. Please continue.
Yes. Yeah, please continue.
Okay. Good afternoon to one and all. First of all, thanks for giving this opportunity. Today my topic is barriers for implementation of BIM and adopting last planner system for the construction projects. This is a literature review paper and this has done under the guidance of Associate Professor Dr. Ashwin Rath. And coming to the contents, these are the contents involved in this. Those are introduction to BIM, benefits of implementation of BIM in AEC industry, and barriers for implementation of BIM, and lean construction, last plan system, benefits and goals of last plan system, finally conclusion. Coming to introduction, BIM is the building information modeling. It is the flow that consists of the number of tools and the number of opportunities as well as challenges for the AEC industry. And in the recent decades, the BIM has developed an idea of 3D, 4D, 5D, 6D, and 7D. 3D is the modeling tool, 4D is the scheduling, 5D is the estimation, and 6D is the sustainable development, and 7D is the facilities management. And the concept of building information modeling is used to build a virtual building before starting the physical work, so that the stakeholders has the more benefits in terms of reducing cost, improving the quality, and reducing the errors, and it increases the productivity. Next, the BIM was started in the earliest of 1960 as a simple computer application, and then after introducing the ArchiCAD in 1970, and actually the real beginning of the BIM has been happened in the year 2000 after introducing the Revit tool. And this building information modeling was initially applied in the design and construction phase only, but it now enhances to maintenance and operations, and it used from the initial stage of the inserts to the whole life cycle of the structure. Coming to the benefits of implementation of BIM in AEC, this has been divided into three categories. Those are owner perspective, contractor perspective, and designer perspective. Coming to the benefits of BIM in the owner perspective, it enhances the project requirement and it meets the early stage of the design. And the cost estimation can be done at the early stage of the design, so that it reduces the financial risk to the owner. And during the design phase only, the 3D walkthrough and the rendering animations has been done, so that it reduces the errors. It reduces the design errors and rework. The complete information of the building has been stored in a single file format, so that the information can be exchanged easily. Coming to the benefits of the BIM in the designer perspective, and it has better visualization and analysis, and it gives more to the owner, and finding the errors and defects at the initial stage of the planning, and the production can be started at the early stage of the drawings. The analysis has been done by using the codes automatically, which are presented in the tools. And the coming to the benefits of support and requirements has been fulfilled. A schedule and cost estimation has been done accurately. It has the data can be shared more easily and quickly. Coming to the barriers to implementation of BIM, although there are many implementation of barriers also will be there, and these barriers can be changed from country to country and as well as the industry to industry. There are many these these are the some of the main crucial barriers for the implementation of BIM. This has been taken from the previous literature reviews, and I grouped this as 5 major groups. There are initial cost, cultural issue, legal issues, lack of skilled persons, and management issues. Coming to initial cost, there is a high cost of software and high cost of training, high cost of implementation process. Coming to cultural issues, there is a resistance to change and lack of cooperation between the project elements. Coming to legal issues, there is a lack of potential for intellectual property rights, lack of BIM standards, lack of insurance applicable to BIM implementation. Coming to lack of skilled persons, there are professional management. There is a negative attitude towards BIM sharing, and there is some misunderstandings about the BIM, and there is a lack of support from the management side. Coming to the concept of lean construction, the main aim of the lean is lean is reducing the waste and giving value to the customer. So in modern construction projects, there is often challenging the time-related uncertainties due to poor communication, misunderstanding, low productivity, and these are happen due to collaboration problems. To overcome these collaboration problems, there is a best technique in the lean construction, that is last planner system. And this in the last planner system, we prepare a schedules like master schedule, phase schedule, look ahead schedule, a weekly schedule, and daily schedule. And this last planner system is also called as the collaborative planning system. And the schedules has been prepared only after all the constraints has been removed, and these commitments has been made when the actual work should be done by each day and each week. by various specialists, which are selected from the activities that are free from constraints. So coming to the benefits of last planner system, those are it increases the workflow reliability and it reduces the time of production, and the communication will increases who involved in the project, and it reduces the day-to-day problems. It improves the quality of work on the construction site. On the site construction, it reduces the stress levels. Coming to the goals of LPS. These are some of the goals of LPS. Those are it improves the collaboration between the stakeholders. It increases the productivity by removing the waste, and it is easy to measure the work progress at every day by calculating the PPC, and the work can be tracked progressively in the standard manner. And coming to the last planner system structural view, this is the structure. Firstly, the project objective has been defined. Then we should plan the work. In the planning, this involves phase schedule, look ahead schedule, weekly schedule, and daily schedules. And for every daily schedule, we calculate the PPC, that is a percentage plan completion. If the task has been achieved, task has been not achieved, we find the reasons by using 5 why analysis, why the task has not been completed, by calculating by doing the 5 reasons. So this PPC can be calculated by using this formula, that is number of completed tasks to the number of assignments. So if the PPC is range, generally this PPC is ranges from 0 to 100%. The lower the PPC, it is the planning should be done weekly. So the PPC is less than 100% indicates that some failure in the production process. But elaborating the reasons for the failure is also the important. Coming to the new parameter of the PPC, that is includes the productivity tracking. So by using this, this PPC will track the productivity of daily by means it is used by dividing the actual productivity of each activity by expected productivity based on the estimated duration. So this is the equation which is used to calculate, and it does not reflect only whether or not task has been completed. It depends on the weekly productivity on each task. In this formula, the time factor also included, so that it tracks the productivity progress, and it allows the early view of potential delays in order to avoid them. When combining this BIM and last planner system, we will it enhance the efficiency of communication among the project participants, and it minimize the project disputes and claims, and while stabilizing the workflow and reducing the construction process variability, and it reduces the limits and barriers from job projects and decrease the amount of uncertainty in the design and construction phases, and it may improve the productivity. Coming to the discussion and conclusion, as I mentioned about that, the main crucial barriers for implementation of BIM are initial cost, cultural issues, legal issues, lack of skilled person, and management issues. These barriers can be avoidable by following certain causes. Means the cultural issues were solved when the stakeholders and the companies can visit the real-time implementation of BIM, so that then they are willing to do their projects by using this BIM, by organizing the several meetings and active visits in the real time. It gives some knowledge about it, and there is a decrease of lack of skilled persons. And the legal issues is a complex issue, and it has a unique response for every project depending upon the participant needs. To avoid these copyright issues, the best solution is that set a contract document ownership rights and responsibilities. If the stakeholders can share the data with each other and they have positive attitude towards BIM, it may avoid the management issues. And the main important issue is the initial cost. It will solve by adding this BIM course in the university curriculum, so that the BIM it gives some knowledge to the students when they enter into the site. And if the government should mandate the implementation of BIM, it will increase the speed up of implementation in the construction industry. When coming to the last planner system, it is applied in the construction, it increases the workflow and productivity, and the PPC will be more when comparing the LPS and non-implementing LPS. And during this LPS, the collaboration is also more through the stakeholders. So by implementing this LPS, it is easy to find the reasons for not completing the task as per commitments by taking the root cause analysis. and it is easy to rectify for the future, so that it increase the productivity and the project will be completed within the time. And these are the some of the references which I followed. Thank you.
Yeah, thank you, Srikanth. Over to Dr. B. Sharchandra, sir. Sir, if you want to give any inputs, you can give your comments.
Yeah, thank you. Mr. Srikanth,
Sir,
yeah, your presentation is good.
thank you, sir.
May I know what are the softwares available in India presently for BAM?
Sir, there are Revit and Revit, Tekla Structure, and 3ds Max and Tekla Structures. These some are using, sir.
Okay, what are the elements? Means what are the building elements we are able to see in the BM software? Different building elements.
Building elements, sir.
Nice. We are able to see the whole structure, no? I think in software.
Yes, sir. Yes, sir. Yes, sir. From
Structural
yes, sir. From
elements we are able
foundation
to
to
see.
top, we will element. Yes, sir.
Structural elements, are you able to see it? Like beam, column,
Yes, sir.
stairs.
Yes, sir. We will see, sir. By preparing the structural model, we will see the details, and then we will do the analysis part also. Means if we take the Revit tool also, we will do the modeling and as well as the analysis, sir. Like that, many tools are there, and Tekla Structures also we will do modeling and as well as analysis part has been done.
Okay, sir. Okay, it's good. Okay, sir. Thank you. Thank you.
Thank you, sir.
Okay, sir. Thank you. Now, I would like to call upon next participant, Arundhati. Are you ready?
Yes, sir.
Yeah, please share your screen and start a presentation. And you please finish this presentation within 5 minutes.
Okay, sir.
Okay.
Sir, Surya sir, 1 minute, sir. Surya. This is Shyam.
Yeah, sir.
Sarath,
Sir, tell me, sir.
how are you, sir?
Fine, sir. Good, sir.
Okay.
How is everything,
Just now
sir?
I seen, sir. Just now I
Okay,
seen. Okay.
Okay, sir.
Surya sir.
Yes, sir. Tell me.
Okay, sir. Okay. No. Continue, sir.
Yes, sir. Yeah, Arundhati, please tell your title and your methodology results. That's it.
Sir.
Yeah.
Please
My screen is visible, sir.
share your. Okay. Go ahead, Arundhati.
Okay, sir. Thanks. Good afternoon, respected dignitaries and all the participants. My name is Arundhati. Today, my topic is strengthening of the BC soil by using the fly ash and coir fiber ash as a tools in the separate layers of the pavement under the supervision of the Hemant Raja sir and Shyam sir, Assistant Professor, Department of KL University, Civil Engineering at KL University. These are the content: abstract, introduction, literature review, objectives, methodology, experimental work, results and discussion, conclusion and references. This is the abstract. Sir, my screen is visible, sir.
Yeah, it's visible. Continue.
Okay, sir. In the study of work, analyzing of the BC soil, coir fiber ash and fly ash, the black cotton soil is collected from the KL University, and to find the improvement of the strengthening of black cotton soil at the percentage of fly ash and coir fiber ash, conducting the engineering and physical properties of soil. The geotechnical properties of varying percentage of fly ash like 0, 2, 5, 10, 15, 20 and 20% with the soil. As a result, all the investigation properties were increased with the exception of severe and moisture content. And also the geotechnical properties of the varying percentage of the coir fiber ash like 0, 10, 20, 30, 40 with the soil. As a result, all the investigation properties were decreased and CBR and moisture content were increases. Variation of geotechnical properties of soil plus fly ash plus coir fiber ash, the results are OMC and CBR increases and MDD and FIS decreases with increase in the fly ash. This is the introduction about the black cotton soil Black cotton soil is also known as the expensive soil. The characteristics of the black cotton soil is great shrinkage and swelling characteristics. It is extremely low bearing capacity. Expensive soils are the soils in the addition of the water and shrinks when it is dry out. These continuous changes of the volume as the settlement and swelling and shrinkage property in the main Montebarnite. The process of the serious problems as a regards to subsequence of the performance of the road. Moreover, the softness upgrade has a tendency to upheave into the upper layers of the pavement, especially when the subgrade layers consisting of the stone soil with the lots of the voids. The physical properties of black cotton soil is vary from place to place, and these are the some of the black cotton soil properties. And next one is the fly ash. Fly ash is also been used as the embankment pavement and minefields, and it has increasingly gained accepted by the Federal Highways Administration. There are two types of the fly ash, Class A and Class F. And next one is the coir fiber. Coir fiber ash. Coir fiber is layer found between the hard internal shell of the coconut and it is outer coating. The water absorption of the capacity of coir fiber is high and it can be hold a lot of water. The advantage of coir fiber is high water holding capacity and great absorption. It is collected from the Kunjunbali near Kunjunbali area and it make it as ash. These are the some of the literature reviews. And next one is the objective to determine the physical and engineering properties of the black cotton soil, fly ash, and coir ash. And next one is to determine the index and strength properties of the like UCS and the seaweed values of various composition of soil, fly ash, and the soil coir fiber ash. Next one is to find the index and strength properties, UCS values and seaweed values of soil, fly ash, and coir fiber ash. To compare the test results of black cotton soil, fly ash, and the coir fiber ash. This is the methodology. First, title of the research work, and next go into the literature review, collection of the materials like BC soil, fly ash, and coir fiber, and next properties of the material, laboratory test, and compare the results and conclusions. These are the some of the experimental work I done. First one is the water content vective analysis for a BC soil, specific gravity, liquid limit, plastic limit, plasticity index, shrinkage limit, Diswell index, OMC and MDD, UCC and CBR test. These are the properties of the black cotton soils. Its properties. First one, water content. I got the 35.5. The specific gravity is 2.72. Vective analysis in that gravel is 0%, sand is 8%, clay is 52%, and silt is 40%. The soil specification classification is CH. That means a high compressibility clay. Next one is liquid limit is 70%, plastic limit is 28%, plasticity index is 42%, shrinkage limit is 11.0, freeze-well index is 8, OMC is 25. Freeze-well index is 80, OMC is 25.58, MDD is 1.52 gram per cc, UCS is 15.0 tons per meter square, CBR is 1.92%, CBR unsoaked is 3.1. And these are the physical properties, engineering properties of physical and engineering properties of the fly ash. Specific gravity is 2.65, liquid limit 42%, plastic no plastic, and freeze-well index is no swelling, OMC is 50%, MDD is 1 gram per cc, UCS is 0.8 tons per meter square. And this is the geotechnical properties of the coir fiber ash. Specific gravity is 2.5. Liquid limit is 22%, freeze-well plastic, no plastic limit, and the freeze-well index is non-swelling, OMC is 14, MDD is 1.014, UCS is 110 per meter square. And next one is results and discussion. These are the some of the tests I followed from these tests. Table 4, it is shows that the experimental of the geotechnical properties of the soil plus fly ash. These are the specific gravity, liquid limit, or plastic limit, plasticity index, FSA, and OMC, MDD, CBR, SOCR, and CBR and SOCR values. These are the graphs as from the table. From the above figures, the liquid limit, plasticity index, and shrinkage limit values are decreased with the increase in the percentage of fly ash, as well as the plastic limit increases with increasing the percentage of the fly ash. And next one is the figures of the FI, that means principal index and specific gravity and maximum dye density decreases with increasing the percentage of fly ash, as well as OMC increases with the percentage of fly ash, and CBR increases until 20%. After that, it slightly decreases with increasing percentage of the coir fiber ash. And next table is the geotechnical properties of the soil with the percentage of different percentage of coir fiber ash. This is the table shown here. From this figure, the liquid limit, plastic limit values are decreases with increasing the percentage of coir fiber ash, and the shrinkage limit is slightly increases until 10%. After that, it is decreases. The plastic limit increases with increasing the percentage of the coir fiber ash. From the slide, the FSI, specific gravity, and the maximum dye density decreases with increasing the percentage of the coir fiber ash, as well as OMC decreases with increasing the percentage of fly ash, and CBR increases until the 20%. After slightly it decreases with increasing the percentage of the coir fiber ash. And next one is the this table shown as soil plus fly ash plus coir fiber ash with the percentages. Fly ash like 0, 5, 10, 15, 20, 25, and the coir fiber ash 10, 20, 30, 40 percentages. From these graphs, the OMC increases with increasing the percentage of fly ash plus coir fiber ash. The MDD and principal index decreases with increasing the percentage of fly ash plus coir fiber ash, and CBR soaked and unsoaked are increases until the 20% of the both ashes. After slightly it is decreases with increasing the percentage of the additives. And next one is the variation of the NCS of the soil plus fly ash plus coir fiber ash with the different percentages. From this graph, the usage value is increases the rises in the amount of the fly ash at 25% and coir fiber ash at 10 and 20%. And our value increases with rise at 20% of the fly ash and 30 and 40% of the coir ash, and it is decreases simultaneously with increasing the amount of the additives. Finally, it is conclusion. Based on the above results and discussion, the following conclusions were made: that to improve the qualities of the BC black cotton soil, fly ash were added. The optimum moisture content is found to be 30.55% at 30% of the fly ash. The specific gravity, liquid limit, plasticity index, shrinkage limit, and principal index decreases at the amount of the fly ash and coir fiber ash in the addition of the BC soil. And next one is the maximum dye density is decreases and the OMC rises at the ash levels in soil ash mix samples. Rises, it means that BC soil mixed with the fly ash and BC soil mixed with the coir fiber ash, and also BC soil with the fly ash and coir fiber ash. The CBR value is obtained from the soil with 20% of fly ash is 8.5%, and the soil 20% of coir fiber ash is 6.2%, which is useful for the embankment or earthwork as a filling material. And the soil with mixing 20% of the fly ash and 30% of the coir fiber ash is 15.5%, which is treated as a separate materials in highway layers. At 10% of the fly ash and 40% of the coir fiber ash, helping to achieve the UCS value such as the 22.5, it can be used as upgrade material in the highway payments. These are the some of the references. Thank you, sir.
Thank you, Arundhati. Over to Sharchandra, sir.
It's good. Your work is good. It's a nice presentation.
Thank you, sir.
Dear participants, Please follow the time schedule and complete the presentation within 5 to 7 minutes. Okay, because we are lagging by 10 minutes. Please complete the schedule presentation within the time. Sir, please continue, sir.
Yeah. So next participant, Venkat Koteshwar Rao. Are you ready?
Ready, sir.
Yeah. Please share the screen. And Koteshwar Rao, you can see that you have to spend only 5 minutes time on a presentation.
Okay,
Okay.
sir.
Then
Okay, sir.
extra 2 minutes, maybe the chair is having any questions, he may ask the question. Otherwise, we'll go to next participant. If you are spending nearly 10 to 15 minutes, it will be, are you getting what I'm saying?
Okay, sir. Yes, sir. I understand, sir.
Yeah, yeah.
Okay, sir.
Don't spend too much time on saying, reading all the things, whatever you put on the PPT.
Okay, sir.
Yeah.
Sir, is my screen is visible, sir?
Yes, yes. Please proceed.
Yes. Good afternoon to all of you. My name is Venkat
Please
Koteshwara.
maximize your presentation. Slideshow.
Yes, sir, slideshow only, sir.
Okay, continue.
Okay, sir. Now it is coming, sir.
It's okay. It's okay. Continue. Continue.
Okay,
Don't
sir.
waste
Okay,
time.
sir. Okay, sir. Okay, sir. My topic is role of protective coatings in enhancing the durability of the concrete, and these are the contents. And we already know that durability means it is the health of the concrete, which is mainly depending upon the permeability. Higher the permeability, lower the durability, and lower the durability, higher the permeability, which is one thing we already known. And these are the factors which influence the durability of the concrete, like environment, water cement ratio, and cement content, and all this. And we all know that as per IS 456 table number 5, we have the exposure conditions like mild, moderate, severe, very severe, extreme conditions. And I will explain it about later why I'm exposing this table number 5. And we already know that the chemical attacks, which is like this one is a chloride attack, and this one is carbonation and acid attack, which is occurring majorly. These are the environmental issues causing on the structures. And this is some of the literature review. And mainly we need to discuss about the problem statement. What is the problem statement means? Comparing the durability of the minimum structural grade concrete with protective coatings and high strength concrete without coatings in chemical exposure conditions, means like the structures in like wastewater treatment plants or sewage treatment plants or any commercial or like in chemical industries. Instead of going for high grade concrete like M40, M50, M60, we can use the minimum structural grade concrete with the protective coating as a barrier. We can reduce the usage of the construction cost, and some sustainability is developed there. So this is my topic. Now I am showing my objectives to determine the durability of M20 grade concrete with protective coatings in chemical environment, and also the comparison of the durability with high strength concrete without protective coatings and M20 minimum structural grade concrete with protective coatings. And this is my methodology. And this is the test duration I have listed out. And this is the mixed design as per IS 456 and 10262 M20, M30, and M40. The experimental setup I want to show. This is I have prepared the
Excuse
samples.
me.
Uh,
Excuse me.
yes, sir.
Yeah. Your slides are not moving.
Not moving, sir.
Yes. It is in the first slide itself.
First slide.
Yeah. Now it's gone. Now it is going. Continue, continue. Please continue.
Okay, sir.
Please continue.
Okay, sir. This is a preparation of the samples. And this is the two protective coatings. I have used coal tar epoxy coating and polyurethane coating. I have coated on two layers. One layer is of 200 micron thickness, and another layer is also 200 micron thickness. Total 400 micron thickness. And this is the polyurethane coating. Mainly, we already know that polyurethane coating is famous for to resist the corrosion, and the coal tar epoxy coating is to resist against sulfates or acids. And this is the chemical exposure I have done. I have taken the acid sample and the sulfate solution, MgSO4 solution of 10% concentration, and acid solution, H2SO4 solution of 10% concentration. And this is the experimental setup of rapid chloride ion penetration test of M20 with the polyurethane and M20 with coal tar epoxy, and M30 and M40 samples without protective coatings I have taken. And this is the experimental setup. I have shown this red wire indicates the NaOH solution and the black wire indicates the NaCl solution, which is used for the RCPT setup. And this is here I am note down in the readings for 6-hour test procedure setup. And these are the RCPT results, which is shown the M20 grade concrete with coat and M30 and M40 grade concrete without coat. Means here we can observe the protective, the barrier coating, which resists the chloride ion penetration into the samples. It's showing very less charge passing through is coulombs, like in 1000 to 100, 1000 to 100, it, in between it is very low charge chloride ion penetration is passing through it. And for M30 it is showing 1264 coulombs, and for M40 it is showing 1179 coulombs. Compared to M30 and M40 without protective coatings, M20 with protective coatings shows the less charge. It means the barriers are which is acting good in good conditions, and it should resist the chloride ion passing penetration. So that in terms of like a sewage treatment plants or any other durability conditions in times of wastewater treatment plants, in those conditions we can use this type of protective coatings with low grade concrete. And this is the sulfate solutions like MgSO4, and I have considered another solution called H2SO4, which is acid solution. Here I consider the M20 grade concrete with protective coatings. So two protective coatings, coat 1 and coat 2, for 28 days exposure, for 56 days exposure, and 90 days exposure. Here we can observe that there is a less variation of strength which is observed, for both the protective coatings compared to coat 1. Coat 2 is more resistance, which means there is a less variation of the strength loss is observed in coat 2, which is a coal tar epoxy coating. And the sulfate immersion of M30 grade and M40 grade concrete. Here we can observe as the day by day the curing is increases, the strength will be increases in water case. And as the day by day in the immersion of sulfates or acids or in chemical environment, the strength is varying or decreasing very rapidly, which means the strength loss is more.
Koteshwar Rao, sorry for the interruption. Please conclude.
Okay, sir.
You have already taken 10 minutes now.
Okay, sir. Okay, sir. Finally, I'm concluding that instead of going for higher grade concrete in severe conditions, like not in terms of the higher structures, in terms of like sewage treatment plants or chemical environment, we can use the M20 grade concrete with protective coatings, which is useful and sustainable also, and also cost effective. Thank you.
Thank you. Sharachandra sir, any questions, or can we move to next participant?
Next part, we will go for next presentation, sir.
Okay. Madhu, are you ready?
Yes, sir.
Yeah, please start your presentation. Madhu, it's 2:40 now.
Yes,
Within 2:45 you have to finish. Otherwise, no, it will be difficult for other participants to finish the presentation within the time.
Okay, sir. Sir, is my screen visible, sir?
Visible. Please continue.
Okay, sir. Good afternoon, sir. Today my topic is delay analysis of road construction projects from contractors, consultant, and engineers perspective. And my name is V. Madhu, and I am doing my project under the guidance of Sri Lakshmi ma'am. So these are the contents. So introduction. First, delay. Delay is the event which obstructs the work happening later than the expected time. So delays are more common in present days, because especially in road construction projects, it takes a huge amount of money in order to complete the project within the budget, but within the specific time within the specific time is not possible nowadays because of these delays. So as per the 2020 and 2021 reports published in the Ministry of Statistics and Program Implementation, overall 146 projects were delayed and 126 projects were reported of cost overruns. 146 projects has overall time delay in the range of 1 to 152 months. The total cost implementation for the 126 projects was 90.92 crore. Their anticipated completion cost is likely to be INR 1,16,551.16 crores. The road projects mainly focus on the national budgets because for all the projects, the budget will be allocated from the central government or the state government. So the categorization of delays. Delays are basically classified into 4 types: critical, non-critical, excusable delays or non-excusable delays, compensable or non-compensable, and the concurrent or non-concurrent delays. So this is the problem statement. So these are the literature reviews which I had referred. So the main objective of this paper is to identify the delays and test agreement ranking and by the relative importance method of analysis, and to study the comparison between all the 3 perspectives, and to eliminate the top 5 causes of the delays in road construction projects. This is the methodology. First, after referring to the literature reviews, I had conducted.
It's okay. Skip this methodology. Go to your results.
So these are the results from each categorization of the group. These are from the contractor related groups, and consultant and design related groups, and manpower related groups, and owner related groups, and material and equipment related groups, and project group related factors, and the external group. So these are the factors that are referred from each group, from each of contractor, consultant, engineer, and overall the combined point of view. I had taken the probability distribution, how much this each factor has causing the impact on the construction project of this delay factor, how much time it, how impact it is showing on this each delay factor. I had represented in the graphical table. So these are the top 10 delay factors which I had identified from the top 50 overall 51 delay factors. These are the top 10 delay factors with the relative important index values of 0.74 from contractor and from each perspective. So these delays can be minimized by detailed scientific investigations and providing fair compensation based on the market values of specification, careful monitoring and regular meetings, use of the sophisticated softwares in the available for the planning and scheduling like the Primavera, or and maintain the continuous site supervision and keep updating of the schedule regularly in order to avoid the delays from the contractors, and maintain regular periodic maintenance of the equipment in order to reduce the delay for equipments, and collaborative working and effective coordination. Here the BIM can be used for doing the collaborative working, and full commitment to the project by all the aspects, and pay contractor must be given their progress payment for payment on the regular basis for the progression of the work, and the owner, consultant, and contractors are recommended to improve communication and coordination between each other. So these are the conclusion. So however the delays are inevitable, or that is unavoidable, how they can be minimized when the root causes were identified. In summary, delay in construction projects are widely area most of the researches are being carried out. Due to wide coverage of construction projects in terms of size, type, geography, and so on, there is still need to be investigate on causes, because these delay causes will vary from one place to another place based on the all the factors such as site conditions and all the aspects. These are the references. Thank you.
Thank you. Next participant, Arifullah.
Yes, sir.
Yeah, please share your presentation.
Okay, sir. Sir, can you see my screen, sir?
Yeah, please proceed.
Good afternoon, everyone.
Only 5 minutes.
Okay, sir. Good afternoon, everyone. This is my presentation about reading of work on material mixed in building construction project. I have completed this project under the guidance of JD Chaitanya Kumar sir and Hamim sir. So these are my contents, and this is my introduction about rework. Rework is an activity in the field that is repeated or undertaken again after the completion of work due to some impending completion of a work due to some impending correction that were necessary to be carried out during the execution of project. So this is material waste. Material waste in construction means any substance or matter or a thing which is generated as a result of construction work and abandoned whether or not it has been proceeded or stockpiled before being abandoned. So this is my literature review, sir. So here my project is about the finding the causes of redoing of work and material waste, and how to examine the impact of redoing of work and on material waste. So this is my methodology, sir. So I have used SPSS software. The software is used to find the means and rank. So this is my data analysis, and here I have also find the eigenvalues, and the eigenvalues which are more than 1.0 are considered as a major rework causes. So these are my tables about rework, material waste, and these are the 5 factors which leads to the major rework causes. So this is how rework affects the material waste. So this is my conclusion. As per this analysis, we can see the major construction problems in industry. The questionnaire survey is used to rank the top factors affecting rework and material waste on construction sites from contractors and consultant perspective. The study indicates the top 5 factors affecting rework on construction sites are error and emissions, lack of labor skills, non-compliance with specification requirements, inadequate supervision, and scope changes. These reasons should be considered and prevented to minimize the rework on material waste. It also helps to minimize the time completion and overrun cost in the projects. Thank you, sir.
Thank you, Harifulla. Sir, anything from your side, sir? Sarath, sir?
No, sir. Please continue.
Yeah.
Please continue
Thank
with
you.
next presentation.
Next one, Syed Amin. Syed Amin, are you there? Okay. So next participant, Kishore Babu.
Yes, sir.
Kishore Babu.
Yes, sir. Yes, sir.
Yeah, please share your screen. And your time is only for 5 minutes.
Okay, sir.
Yeah.
Sir, is my screen visible, sir? Sir, is my screen visible, sir?
Yeah.
Yeah. Okay. Good afternoon, everyone. And I'm Kishore, and I have done a project on seismic response mitigation of a base isolated structure with the dune mass damper. And I have done this project under the guidance of the Vinod sir, assistant professor KLD University. As we all know, not moving, sir. One second. As we all know, earthquake is the major cause for the damage of the building, and many research is going on to mitigate that. That means to reduce the damage caused by the earthquake on the structure. So here that mitigation maybe the element strengthening, global strengthening. Element strengthening means the strengthening of the materials inheritance. That means the material should be strengthened to the durability. And for the global strengthening, we can add some other elements to the structure that decrease the damage of the structure when earthquake occurs. Here, sir, PPT more easy. Is PPT moving, sir?
No, it's not moving. Kishore Babu, you can.
Sure. Sir, there's problem with the laptop, sir. It's not moving.
Then please exit. And next participant, Ram Gopal Krishna. Ram Gopal Krishna.
Sir, good afternoon, sir.
Yeah, you can start a presentation. Only 5 minutes.
Yes, sir.
Yeah.
Good afternoon, sir. My screen is visible, sir.
Yeah, it's visible.
Good afternoon, sir. Good afternoon, and all. I have in this conference, I am published my paper. In my topic is structural performance of range building system under general loading. Outline of the topics is the introduction, literature review, objectives, methodology, and results and discussion, conclusion, and references. Part of all of the pre-engineering building introduction. Pre-engineering building systems are components manufactured in factory and assembled at the site and stage structures. It will be constructed very easily and easy to construction. In manufacturing process very easy. Time taken process is very reduced. It will be used for the pre-engineering building system. Applications of the PEB structures. It will be used for the different structures like industrial factories, workshops, warehouse, car parking sheds, cement plants, and commercial and institutional purpose, agriculture purpose. It will be used for the pre-engineering building system concept. Comparison between the pre-engineering building system and conventional building. Conventional building means traditional and fabricated and welding and cutting are used in this concept. And pre-engineered steel buildings constructed using the steel build-up sections. It is used for fabricated on the site. Construction it is used for the bolted connections. The main the components of the different components are used in the PEB structure. The main objectives of the in this project pre-enabling system, developing the model pre-enabling system, different code books are used. The dead load and live load taken are IS 875 part 1, part 2 are used. Wind loads are taken based on IS 875 part 3 are used. And it will be used for this concept. I use it for StatPro software. And methodology of the project in literature review, problem statement, development of model using StatPro, analysis and design of the PEB structure with the different loads, conclusions. I have developed in this software used for the open structure visual to concept are used. I have developed the so many commands are used. Open structure visual is the most advanced then easy to develop the project. It will be used for in this concept. Like it will be frame models are taken in this model. I have developed the model. It will be in different tools are used in this concept model of the structure.
Hello.
Sir, what happened?
What happened?
Scroll out less, sir. The page.
Conclusion, sir, if possible.
Yeah,
Time
please
is going
conclude.
on.
Or else manually you can click on the slide you want.
Yes, sir. Okay, sir.
Yeah.
conclusion, it is used for that in this project enabling concept. The tube sections and different ISB sections are used, and it will be more advantage of the tube sections will provide to reduce the shear forces, and that like if wind forces are acting on the structure, it will be reduced. The tube sections is very high, and Indian standard sections are used in this concept. It will be very low amount forces are reduced in this concept. I have preferred only in my research point of view. Tube sections are provided. It will be more preferable. Thank you, sir.
Thank you, Ram Gopal. Kishore Babu, are you ready now?
Yes, sir. Yes, sir.
Yeah, present now.
Good afternoon, everyone. This is Kishore, and I have done it on seismic response mitigation of a base isolated structure with a clean mass damper, and under the guidance of Vinod sir, assistant professor KL into University. And these are the contents of the topic: the introduction and literature review, problem statement, and the objectives, methodology, results, and discussions, references. And as we all know, earthquake is the main cause for the damage of the structure, but we cannot permanently remove the damage, but we can reduce the damage to some. That is the either by element strengthening or the global strengthening. Element strengthening means the strengthening of the element, material we are going to use skill, and also global strengthening means we are adding.
Hello? Hello, Kishore. Hello, Kishore. Hello, Kishore.
Sir, it is
Yeah,
a device.
Continue.
So it is a device mounted in structures. It to reduce mechanical vibrations, consisting of a mass mounted on one or more isolators and the damper, and with incorporating the value we have designed in the SAP software we for the pushover. And this is the methodology, modeling and analysis and comparison results, conclusions. And the model we have taken in the SAP is this, is a 2D frame, and it is located in the seismic zone of 5. And the lead rubber bearing design procedure, sir, the design time period must be greater than the must be taken as 3 times the time period we have taken here. And in any bearing, the main incorporated in the SAP software is the stiffness of the that what we call it, we have taken the stiffness of the bearing we have taken. And next, by and also the shape factor is also most important. The shape factor is equal to load area by something loaded area by unloaded area is the shape factor. And next, these are the value that we had to incorporate in the SAP 2000 software. After the calculation of the all the above these steps, we have got these values. And the friction pendulum bearing, coefficient of friction plays a major role here. The coefficient of friction means here the friction pendulum bearing, the ball we have the over the bearing that ball and the plate, that is mean the coefficient of friction. And that after that time period, here also the stiffness, as it is the bearing, the stiffness is the major thing here. And after the calculating all these values, we have got this operate in the SAP 2000 software. And also we have to design for the twin mass damper. Here the main is here. The main thing is the damper mass to main mass ratio. Either and in the previous two, the if what we going stiffness is the main thing, and this is the here damper mass to main mass ratio is the main thing. And we have taken in the twin mass damper must be designed for the damper mass ratio of 5% to 10%. Here we have calculated for the 5% mass ratio. For this, we have calculated the what we call stiffness and the damping values. And after incorporating this, this is the pushover of the structure with LRB and TMD, sir. And this is for the FPB, friction pendulum pairing, and TMD, sir, twin mass damper. From the, here, two values, you can see the minute variance has happened in the performance points. That means in that minute points, we can know that FPB works well with the combination of TMD than the LRB. But here we can from the these points we can tell that FPB works better than LRB, but FBB it takes the maintenance. You must have done the regular maintenance for FBB. So many of them are using for the letter bar bearing, and as we from the here we can conclude that this combined technology may improve the seismic performance of the building, but when we incorporate these two in the building, the cost of the building also that has also must be studied in the future studies. And these are the references we have taken. Thank you, sir.
Okay, thank you. Sir, anything, sir? Sharchandra, sir?
Nothing, sir. Please continue, sir.
Yeah.
Explain.
Next one, Brahmarambika Devi.
Sir, yes, sir.
Yeah, please share your screen. Only 5 minutes, ma, for you also.
Yes, sir. Sir, my screen is visible, sir.
Yeah.
Good afternoon, everyone. My topic is extra strengthening of reinforced composite cement concrete beam using CFRB sheets. These are my contents: background, introduction, objective, literature review, outcome from literature review, research program and action plan, experimental work, results and conclusion and references. Background of my background of retrofitting. Nowadays, retrofitting is expanding its wings in the historical, public, and private importance structure to increase the lifespan of the structure, to provide to be a better economical consideration and provide shelter to problems rather than the replacement of the structure. It is the one of the best option to make an extending inadequate building safe against future probable earthquakes or other environmental forces. Retrofitting is the process of adding of a new features to the old building, heritage structures, bridges and etc. Retrofitting reduces the vulnerable of damages of an extending structure during an near future seismic activities. Introduction. Retrofitting techniques are reduced for concrete construction which are vulnerable to damage and failure by seismic forces and heavy.
Hello.
Sir, yes, sir.
Yeah, why are you reading all this? Straightly go to your methodology results.
Yes, sir. These are the details of project. Grade of concrete is M40. Number of concrete cubes is 12. Beams is 12. Type of beams is a control concrete beams. 4 composite beams is a fly ash plus GGBS. 4 of glass fibers and glass fiber reinforced concrete beams. Using method is wrapping. These are materials are used: cement, fine aggregate, coarse aggregate, GGBS, and fly ash and air glass fibers. Details of the beam is size of each beam is 0.15 meters and 0.15 into 0.17 meters. Reinforcement bars are used is 4 number of 12 mm dia and longitudinal bars, 8 mm dia for So with 100 mm center to center, this is my methodology. Literature review, collection of materials, property test of materials, M40, mixed design, design of beams, casting and curing of beams and tubes, wrapping the beams after curing and testing, results and conclusion. These are my experimental work for fine aggregate. Specific gravity test of on fine aggregate is defined as the ratio of weight of a given volume of aggregate to the weight of the equal volume of water. Specific gravity of fine aggregate is 2.66 mm, 2.66, and specific gravity of coarse aggregate is 2.97. Mixed design mixed design of concrete. Grade of concrete is M40. Mixed design mixed property is 1:1.34 is to 2.55. Cement water cement ratio is 0.35. These are my beams while casted. Mixing while curing, mix of resin and hardener, applying epoxy to the beam, and testing in loading frame. Results. In a control concrete beam, the failure load occurs at 53.6 kilonewtons and maximum deflection observed is 2.09 mm. And the beam failed with a deep flexural crack at the center position of the beam, extending up to the compressive zone of the beam. In the control concrete beam retrofitted with CFRB sheet, the failure load occurs at 72 kilonewtons and maximum deflection observed is 1.28, and the shape of the crack is not visible due to the CFRB sheet. The flexural strength is more in a control concrete beam retrofitted with CFRB compared to the control concrete beam. In composite concrete beam, the failure load occurs at 49 kilonewtons and maximum deflection observed is 2.05 mm. And the beam failed with a deep crack at the center position of the beam. And with the composite concrete beam with the CFRB sheet, the failure load occurs at 67.7 kilonewtons and the deflection observed is 1.34 mm. The shape is not visible due to the CFRB sheet covered in the beam. In composite concrete beam retrofitted with CFRB sheet, getting more flexural strength compared to the composite beam. In glass fiber reinforced concrete beam, the flexural load occurs at 47.9 kilonewtons and maximum deflection observed is 1.92 mm. And the failure load with the hairline flexural crack at the center position of the beam.
Brahmika Devi, please tell your final conclusions now. Why are you reading all those things?
Sir. Okay, sir. Conclusion. Flexural strength of composite concrete beam with CFRB, control concrete with CFRB, and glass fiber reinforcement concrete beam with CFRB getting more flexural strength compared to the normal beams. In a deflection of composite concrete beams with CFRB sheets and glass control concrete beam with CFRB sheets and glass fiber concrete beams with CFRB sheets is getting less deflection compared to the normal beams. On average of overall testing beams, there is an increasing of 39.35% in the flexural strength and decreasing of 63.72% in deflection. In glass fiber reinforcement concrete beam retrofitted with CFRB sheet get more flexural strength and less deflection compared to the composite and conventional beams with CFRB. And also glass fiber concrete beam gets more strength and less deflection compared to the composite and conventional concrete beams. Now these are my references. Nice quotes of in Indian standards. Thank you, sir.
Okay, thank you. Next, Lasya, are you ready?
Hello, yes, sir.
Yeah. Lasya, listen carefully. Your title, your results, and your conclusions. That's it. Okay.
Yes, sir.
Yeah.
My title is, good morning, sir. Good morning, everyone. My title is Numerical Investigation of Thin-Walled Cold-Formed Steel Back-to-Back Channel Sections. These are the contents I'll be presenting. Abstract. Objectives to numerically investigate the specimen through finite element software and to examine and compare the errors and performance of each specimen and to develop an optimum back-to-back CFS wall panel. CFS wall panels are made from structural steel with the chain of dies. Dies are a mechanical machine tool which is used in manufacturing industries to cut and form material to a desired shape or profile. CFS are preferred for low and mid-rise buildings than high-rise structures. Methodology: literature review, finite element modeling, simulation results, and conclusion. These are the specimens used in the presenting upcoming model. These are the material properties. These are the models. The first model has 6 spot wells, 3 in row and 2 in column. These are the load and displacement curves. Model 2, Model 3, Model 4, and Model 5. In Model 1, proportionality limit ends when load is equal to 0.37 into 10 power 6 newtons and the corresponding displacement is 0.1 mm. Whereas in Model 2, the proportionality limit ends when the load is equal to 2.67 into 10 power 6 newtons and the corresponding displacement is 0.49. Whereas in Model 3, the load is at 0.17 into 10 power 6 newtons and the corresponding proportional displacement to the proportional load is 0.07 mm. Whereas in Model 4, load acts 0.456 into 10 power 6 newtons and displacement is 0.133 mm. Whereas in Model 5, the load acting is 0.294 into 10 power 6 newtons and the displacement is 0.194. By the above collected data and with the consideration of Hooke's law, we can conclude that Model 2 is the best among the 5. Hence, Model 2 can be used as wall panel when the external load is less than 2.82 into 10 power 6 newtons. Thank you, sir.
Thank you, Asya. And next participant, Sai Srinivas, are you ready? Hello. Hello, Sai Srinivas.
Sir, am I audible, sir?
Yes. Please start your presentation.
Sir.
Sai Srinivas. Okay, next participant.
Sir, I'm sharing so 1 minute.
Yeah, please share.
Yes. Yes, sir. Good afternoon to one and all. My topic is about performance study on different beam column connections for precast concrete frames under the guidance of Mr. J.D. Chaitanya, sir. Why precast? Precast is an practice of assembling different components at a controlled environment. By doing this, we can reduce the cost, material, manpower, and it is also helpful in reducing the shuttering and scaffolding. Because of the supervision in the factory, the quality of these components are very improved and high quality than compared to the conventional concrete. In spite of these advantages, the usage of precast concrete or prefabricated systems are less when compared to the conventional and steel systems. This is because of their discontinuity in the segments, and the main moment transfer is through the connections between the each segment. So So the joint and connections are important in this type of systems. Some of the joints and connections are dry and mechanical connection, wet connection, and hybrid connections. So in order to increase the strength or stability of the precast connection, we should mainly focus on the connection behavior. So these are some of the literature survey based on the segments and their connection behaviors. All of the researchers have done many work on cyclic loading, monotonic loading, and impact loading, and gravity loading. Most of the work is on gravity loading, and some of the work is on the cyclic loading. These two observations authors made an study on concrete damage plasticity index, which is used to capture the non-linearities of concrete in developing a FE model. Main objective of our study is developing a FEM model, and investigation is need to be conducted on different failure models of the connection for gravity loading condition. The study will help in identification of parameters that influence the connections, by which we can improve the performance of the connections. And these performance are compared with the monolithic frames. The methodology. At first, before developing a FEM model, we should calculate the concrete damage plasticity. It plays an important role in capturing the non-linearities of the concrete. So it allows.
Please, we are running out of time. Please go to your results and conclusion.
These are some of the parameters which influences the concrete damage plasticity. It plays an important role in FEM developing. These are the damage parameters, which is one in compression and the other in tension. These are empirical formulas. The main source to calculate this is ultimate strength of the concrete and under compression and tension. These are the steps required for the modeling. These are some of the steps: are creation of parts, assigning the properties, assembling, modeling, creation of steps, which includes loading and other history on field outputs, creation of interaction of the parts, assigning of loads, and meshing. In developing FEM model, the mainly assigning the property plays an important role. By assigning the correct property, we can achieve the most reliable structure in FEM model. These are some of the properties which I have used in our developing a FEM model. These are the process of assigning the properties to the particular section. And interaction. It plays an important role in creating a realistic behavior in FEM model. In our study, embedded region is created to reinforcement on concrete to develop a bond slip effect of the reinforcement, and steel plates and bolts are used to surface to surface contraction to the concrete to improve the concrete action, and the rigid sections are developed for the reference point in order to apply loads and boundary conditions. These are the assembling of the parts in abacus, and the meshing of the parts in a way of various parts. These are the results of the monolithic structure I have selected. First one is a displacement in the y direction and negative y direction, plastic strain at the joint, active yield of the section. From the observations on the monolithic, it is considered that a 10 kilonewton load was applied at the beam end with a linear increment. Failure of this section occurred at 7 kilonewton at a minimum displacement of 1.8 mm. Yield strength, yielding of the section started at 2.4 kilonewton at 10th increment. These are the observations formed from the monolithic section. By considering this as a benchmark, we are developing a precast segment and analyzing the precast segment and conducting a parametric study on this section. By this, we can develop a reliable and most realistic FEM model in precast segments. This will help in the further investigations of the studies. Thank you.
Thank you, Sai Srinivas. Now, the next participant, Amin, you can present now. Syed Amin.
Am I audible, sir?
Yeah, please share your screen. Hello, Amin. Are you there?
Yes, sir.
Okay. Next participant, Tej Mahendra Sai.
Sir.
Yeah, are you ready?
Sir. Yes, sir.
Yeah, Tej Mahendra Sai, please share your screen.
Is my screen visible, sir?
Yeah, it's visible, Teja. Please proceed.
Good afternoon, sir. My topic is numerical modeling and analysis of structural behavior of cold form steel composite wall panels under axial loading under the guidance of Himad Kumar, sir. Coming to introduction, cold form steel is a common term of steel product shaped by cold working process, which can be made by rolling, pressing, stamping, bending, etc. Generally, in steel there are two types: cold form steel and hot roll steel. In case of hot roll steel, we make the products by using welding techniques which requires heat. But in case of cold form steel, this can be made by means of rolling and pressing. This can be useful for modular houses, where the products are manufactured in a factory and easy to construct in the site. It has begun since 1950 in both United States and Great Britain. Due to the lack of proper design and material information in building codes, it is very rare. It was very rarely using. The acceptance of cold form steel is very limited due to this lack of proper design. Why cold form steel? It is very light in weight and uniform quality. The entire sheet has uniform quality and this can be reusable. If we have constructed a building by using the cold form steel, we can easily remove the components of this and we can replace those with the new we are constructing the building, and it is very easy to construction and eco-friendly. The objectives of this project is to undertake extensive parametric studies and examine the effects of the important parameters on the structural performance of CFS, and to develop finite accurate element model of CFS infill with general loads, and to develop accurate design. These are the literature reviews. Coming to this, I had taken North American standard of cold forming steel, where these are the different types of the members. There are stud, joist, and the track for in channel angle. Here, the designation thickness refers to the strength in terms of KSI, kilo pound per square inch, and these are the minimum base steel thickness in inches and mm. We consider generally from 1.2 mm to 2.97 mm as per the steel. But according to the design thickness, we increase from 1.087 to 1.146. These are the properties of the infill material and the properties of the sheeting I had taken. This is the model I had generated to develop to check the design. Here I have taken the boundary conditions as fixed and the load is applied like this by using the abacus tool. It is the result I have got. These are the results of the different specimens I had created with the different material types, and I had got without filling 13.6 tons at the failure load, and the top is 36.5. The load bearing capacity is maximum 36.5 tons. I am concluding with the infill material. The infill material carries load higher than the without when we use the walls without infilling material. So the load bearing capacity increases with the increase in thickness of the cold formed steel and as well as density of gypsum. These are the references I have taken, and thank you, sir.
Yeah, thank you. The next participant, Viram Srija. Srija, are you there?
Sir, my PPT is ready, sir. Now, is it
Yeah,
visible,
yeah.
sir? I mean, Syed Amin.
Yeah. Proceed.
Thank you, sir. Can I start, sir?
Yeah, you can start.
Okay. Good afternoon, everyone. So, my project is identification and analyzing risks using chosen method in construction projects. So, this is the list of contents. Introduction. The risk is assumed as a deviation from the desired level. It can be positive or it can be negative. So what is the importance of risk? Why are we going to take risk in this paper? So more than other industries, the construction industries or more prone to risk and often are not dealt adequately. So it results in bad performance, increase in cost and time delays. Therefore, the risk analysis is important for the selection of a suitable project and the coordination of construction works. So what is the problem statement being taken in this paper? So the formal risk analysis and management techniques are rarely used, employed in construction industry owing to the lack of experience and knowledge in the area. The industry also holds this belief that these techniques are not suitable to be employed in construction projects, much as in the manners as employed in the other industries. So this perception of risk by contractors and the consultants is mostly based on the institution and the experience. So hence, this risk analysis is important. Basically, in India, risk analysis is not much done for all the projects, and it will lead to most of the problems like increase in costs, delays, and everything, and it also affects the project goals. So what are the objectives of the studies? The objective of my paper is to first to identify various risks, those are uncertain to occur in the construction projects, and then categorize those risks depending on probability and impact, and then categorize them as high, moderate, or low. So then after that, after categorizing those risks, then we do risk analysis, and then identify which risks are higher and which risks are lower. So this is the methodology. First, we find the objective and the scope of the project. We know. Then, from the literature review, from the previous literature, from previous authors, what they have found, which risks they have found, we will find them. Then we'll identify those risks, and then categorize them based on high, low, or medium. This is the methodology. So. Here in this paper, there are 6 categories of risks are identified. That these are design, financial, social and political, environmental, logistics, and management. So these risks are further divided into further categories. That the economic risk, it is 5 categories are divided. Then in design, 3 are identified: social, management, and environmental. These risks have been found. So in this paper, I have chosen matrix method. Matrix method is to identify the risks. So around 20 risks have been found, and then I have taken a scale of probability and impact. So then after the identifying those risks, I have designed a questionnaire and sent to around 100 participants, and got the results. And these are the results. These are the average results I have found, impact and probability. And from these results, I have been drawn a matrix. This is the matrix. Here the regions derive different regions derive different levels of risk. The lighter green region is have very low risk, and then increasingly up to the darker red, it will increase. Like in the moderate green, the risks are low, moderate, high, and very high. So also I have found who the risks is going to be allotted, who on the mostly on the risks are being allotted. So from client and contractor perspective, who are being more allotted for the risks. So these are the results. This is some literature review I have taken. So I want to conclude that the top critical risks from the results were found to be improper resource allocation, bad weather conditions, unavailability of manpower for construction, unsatisfactory skilled staff. Among them, the highest being is the improper resource allocation. Based on these findings, it is safe to conclude that the majority of the construction projects lack a systematic risk management approach. So there is no proper risk management approach now being properly used. So we have to apply risk management in the proper day-to-day construction projects, and the risk management is carried out in informal manner. These are some references. Thank you. Is there any doubt, sir? Hello.
Okay, please leave the section. Thank you for your presentation.
Participant Viveka.
Okay, thank you.
Sir, Srija.
Yeah, Srija, please present.
Sir, is my screen visible?
Yeah.
Good afternoon, everyone. The topic is finding the suitable painters, living techniques and barriers in the offset housing construction in India under the guidance of C.H. Manikama and T. Venkateswar. And these are the contents which are introduction, objective, literature review, methodology, results and discussion, conclusion and references. Coming to introduction, offset construction means the work that is done in factories rather than on building sites. The construction industry being transformed by a variety of modern techniques of the construction. Offset construction has been advertised as a new technique in building, which has the capacity to attain faster construction, greater quality at a cheaper cost, and with less workloads at the site. Offset construction obtains strategic and operational benefits from BIM. It results less rework changing during the modeling phase and real execution time also. Lean construction is another quality improvement strategy that optimizes the whole building project in order to successfully meet the customer demand. This is the pictorial representation of comparison between modular construction schedule and traditional construction schedule. Um, Rather than the building construction at a site, we will do the building construction at plants and install the model at the site, at the construction site. By this way, we can save the time. 30 to 50% of time we can say, and this is the objective. My purpose of this study is finding the suitable BIM tools and lean techniques and barriers in the offset housing construction in India. According to the survey, the barriers are being analyzed as well as BIM tools and lean approaches is strong in offset housing construction. And these are some literature reviews which referred. Coming to methodology, I prepared questionnaires to survey, and total 80 responses has been collected from the contractors and project managers who has experience in offset construction. And the questionnaires has been sent through mails, and individual opinions has been collected and evaluated by using the Likert scale. This is the mean method formula to analyzing for ranking. And in future, the continuation of the project, I will be design of offset construction by using the Revit software. These the details, and these are the results which I got by surveying. Questionnaire survey. These are the BIM tools, which are Revit, Tekla Structures, AutoCAD, StatPro, Archicad, Vectorworks, Navisworks, Allplan, SketchUp, and 3D Max. This is the graphical representation of BIM tools according to the questionnaire survey which I got. These are the lean techniques, which is just-in-time value stream mapping, last panel system, continuous improvement, visual management, full system, 5 years, total productive maintenance, and first run study automation. This is the graphical representation of lean techniques. This is the barriers. This is the graphical representation of barriers. This is the top 3 tools and techniques and 3 barriers of offset construction. The BIM tools are Revit and Tekla Structures, AutoCAD. These 3 are top 3, which I got according to the survey questionnaire survey process. And then lean techniques are just-in-time value stream mapping, last planner system. These are the 3 got, and these 3 are barriers. Coming to the conclusion, the data collected from the respondents using questionnaire survey was analyzed by using Bim method, and in Bim tools, the Revit, Tekla structures, and AutoCAD has the highest significance value, and in Lean techniques, just-in-time value stream mapping and last planner system has the highest significant value and listed top in this group. And the main crucial barrier which affects the offsite housing construction or a design and construction culture, lack of knowledge and owner come client reluctance. By overcoming of these barriers, it may speed up the process of implementing offsite construction and building project with integrating the lean and Bim techniques. These are the references which I preferred.
Thank you, Srija. And next participant, Viveka, are you ready?
Yes, sir.
Yeah, please start your presentation.
Good afternoon, respected chair, session coordinators, and all my dear speakers. Today, I would like to share my paper on the topic Stabilization of Expansive Soil and Implication on Using Rice Husk Ash and Marble Dust as Additives under the guidance of Mr. K. Sham Chamberlain and Dr. Hamim Syed Jilani. So, coming to the contents, these are the contents. Introduction. So, black cotton soils are problematic for civil engineers because of the unconventional behavior. So as to stabilize the soil, there are different treatments, that is physical and chemical treatment, to increase or to maintain the stability of the soil. So as to attain the stability, we use different additives like fly ash, lime, and some materials like lime kiln dust, cement kiln dust, concrete fines, industrial waste such as bitumen, fly ash, marble dust, granite dust, and solid waste such as rice husk ash and etc. are used. So the main proposal or the project proposal is on the marble dust, which is an industrial waste, and also the rice husk ash, a solid waste. The reason that I have picked up these materials is because they are economical and they are easily available. So the rice husk ash and marble dust are collected from the particular location, and then they are mixed with soil in various proportions, like different percentages, like 2 to 12% till 2 till 12% in RHA and 5 till 20% of marble dust. And the different laboratory tests were conducted of these particular proportions, and they are optimized proportion is arrived, and these results are compared with natural soil and investigated on behavior and type of the soil. So the main objective is to study the influence of waste materials such as marble dust and rice husk ash, and the characteristics of black cotton soil, and also to understand the behavior of black cotton soil mixed with rice husk ash and marble dust in various percentages, and also to carry out the experimental analysis and observe the changes in the properties of soil, that is like maximum dry density, optimum moisture content, liquid limit, plastic limit, California bearing ratio, etc. So the different materials that I've collected are black cotton soil, which is also known as expansive soil or also known as soft soil. So black cotton soil is a clay soil varying from clay to loam. It is, the color is like generally light to dark gray in color, and the cotton is grown in this kind of soil. And the other material is rice husk ash. Rice husk ash is an abundantly available and renewable agricultural byproduct from rice milling in India. So this is also uh, an agricultural waste product that accounts for 20% of the world's rice production, with total of 649.7 million tons per year. So this is a solid waste product that is produced during the rice milling process. The output is expected to reach over 108 tons per year globally. It is produced in Nigeria at a rate of 2 million tons per year, and also in India at a range of 88 million tons per year. It has been extensively in the past for soil improvement. So in a rice farm, rice husk is common waste product. It is made of around 30 to 50% of the world's food producers. And coming to the marble dust is obtained from
Viveka,
the
sorry, can you please straight away go to your results and then conclusions? Don't spend time on explaining all these materials.
Okay, sir, sure. And these are the different properties and the literature review, the papers that I've collected and studied. This is the methodology. And the experimental work is the soil, that is the black cotton soil that is collected from NTPC Nunna, Vijayawada. And the rice husk ash is collected from Sri Venkateshwara Rice Mill, Nunna. And the marble dust is collected from KGN granites from Gollapudi. So these are the experimental results. The results of the soil, the liquid limit is 68%, plastic limit is 28%, plasticity index is 40% of the black cotton soil. If you see the free swell index, it is obtained as 40%. This is the direct shear test and the vein shear test. The results of the vein shear test. Shear strength of the soil specimen that obtained is 0.092 kg per centimeter square. Compaction tests, there are two different tests that are used, standard Proctor and modified Proctor. And these are the major differences in standard Proctor and modified Proctor. And coming to the California bearing ratio, these are the results of the soil that obtained. Water content is obtained as 37%, specific gravity is 2.67, followed by free swell index, optimum moisture content, maximum dry density, unconfined, compressive strength, and CPR value soaked and unsoaked. Rice husk ash, the properties of the rice husk ash. Specific gravity is obtained as 1.93 and followed by maximum dry density, optimum moisture content, angle of internal friction, and CBR soap 8.54. And if we see the results of soil plus percentage of rice husk ash, these are the values that obtain for specific gravity, liquid limit, plastic limit, plasticity index, free swell index, optimum moisture content, maximum dry density, etc., with different percentages of rice husk ash and soil. The rice husk ash is 0, 2, 4, 6, 8, and 10%. So these are the results that obtained. If we see the graphs, the relation between specific gravity and the percentage of RHA with soil and liquid limit, plastic limit, and plasticity index, these four are reducing with respect to the increase in the percentage of the RHA. And if we see here, free swell index and maximum dry density is also decreasing with respect to the increase in the RHA, and optimum moisture content and CBR are increasing with respect to the increase in the percentage of RHA and soil. So these are the properties of the marble dust. If you see the marble dust, these are the obtained results, liquid limit, plastic limit, and the different properties with the 0, 5, 10, 15, 20, 25, 30, 35 percentages of marble dust. If you see the results here, the specific gravity, free swell, plastic, and liquid limit are decreasing with respect to the increase in the percentage of the marble dust. And the optimum moisture content is also decreases with respect to the increase in the percentage of the marble dust, and maximum dry density and the CBR values, these two increases with respect to the increase in the percentage of marble dust. If we see the various properties of soil with respect to rice husk ash and marble dust, these are the values that obtain different percentages. And if you see the results, these are the results that obtain with respect to different percentages of marble dust. And the results and discussions, coming to the results and discussions, we can observe that the soil sample is Diswell index decreases with 40% up to 24% when RHA with RHA 14% and when MD is added, which shows the improvement of swelling nature. And if you see, these are all increasing with different properties or decreases in rice husk ash, like liquid limit, plastic limit, shrinkage limit, plasticity index decreases, while optimum moisture content and California bearing ratio increases. In marble dust, all of the parameters increases with while maximum dry density and California bearing ratio increases. And we can see different results. There is a decrease in the liquid limit of soil about 33% with addition of 35% of marble dust, whereas in case of 10% of rice cash with decrease in liquid limit is 48%. It was noted that the plasticity index of the expansive soil is decreased by 15% with the addition of 35% of marble dust, while in RHA decrease with noticed to be to 23.7%. So we can see the results, which shows the improvement of the soil when the additives are added. The summary is that samples are collected and they are tested in the lab, and it is concluded that after analyzing all the data, it has been said that marble dust and rice husk ash are very much effective for stabilizing the expansive soil. As the percentage of marble dust increases, the maximum dry density and CBR increases, while the other parameters decrease. And if we see RHA, as the percentage of RHA increases, the optimum moisture content and CBR increases, while the other parameters decrease. Though RHA and marble dust are effective, mixing of marble dust with the soil is found to be more easy when compared to rice husk ash. So the workability of marble dust while mixing it with wet expansive soil is more. The procedure of mixing rice husk ash with the wet soil is found to be a little bit hard. The procedure for burning the rice husk can to convert it into ash makes the overall method of using rice husk ash as a soil stabilizer more. So these are the references that I have referred. That's it. Thank you, sir.
Thank you, Viveka. It's really nice work, and we can see the quantity of the work you have done. Keep it up.
Thank you. Thank you, sir.
And the next participant, Sai Praneeth. Are you ready?
Yes, sir.
Yeah. Please share your presentation. Only 5 minutes. Methodology results.
Yes, sir. Sir, is it visible?
Yeah, it's visible. Please put it on slideshow.
Okay, sir. Good afternoon, everyone. My topic is about the role of emotional intelligence in construction safety management. These are the contents. Introduction. Emotional intelligence, otherwise known as EI, is the ability to understand, the use, and manage your own emotions in positive ways to relieve stress, communicate effectively, empathize with others, overcome challenges, and diffuse conflicts. However, some recent researchers have shown that a plausible way of fascinating the interest in the improvements of construction projects, performance planning, judgment, and decision making of the project team members by enhancing the emotional intelligence of a person. These are some of the literature reviews I gone through. Problem statement. Project team members' ability on managing their emotions is vital for the project success. If a project team does not manage their emotions mindfully, it might ruin the project success. Therefore, this study attempt to study the emotional intelligence of project team members and other workers to determine and examine the effects of mindfulness practice on EI of project team members, which might help to enhance the performance of project team members to achieve their better project success. Objective: to identify the emotional intelligence, interpersonal skills, transformational leadership of project team members in the construction industry, to develop better teamwork so employees with higher emotional intelligence naturally work better as a team for several reasons in the project management, personally to develop their human skills. This is the methodology of my project. These are the results I got by doing the online questionnaire survey, mean and rank. This is the graph representation of my results of mean and rank. Conclusion. The conclusion of this study has furnished viewing that project control employees can use human competence, which include the 3 human skills discussed in this research, to enhance security control in construction projects. Additionally, leadership and executive of security control duties in combination with oblique control from interpersonal skills publicize the development of security atmosphere that is an essential main benchmark of construction security responsibilities. These are the some of references. Thank you, sir.
Thank you, Sai Pranit. Next participant, Shyam Prakash. Shyam Prakash, are you there? Shyam Prakash. Okay. So next participant, Sairam. M. Sairam.
Sir, yes, sir. I am available, sir.
Yeah, please share your screen.
Okay. Good afternoon to one and all. My topic is seismic soil structure interaction of RC frame building, supported and foundations under the guidelines of Mr. Lingeshwaran, sir. Sir, contents recorded in this presentation. Coming to the introduction, a soil structure interaction again determines the response of the structure during seismic activity, which is the mechanism in which the response of soil particles, earthquake ground movements of the structure. Structural response affects the movement of the soil mass. Collective response of the structure, the foundation activity by the seismic soil structure interaction of this analysis. This mainly consists of interaction between soil and the structure built upon it. Primarily an exchange of mutual stress whereby the moment of the ground structure system and the influenced by the both type of ground and the type of the structures, especially applicable to areas of seismic activity. Various combinations of the soil and structure can be either is to be movement and the significant damage in these types of soil structure interaction. There are two types: modeled substructure approach and direct analysis approach. These are the recording literature review I taken from these reference papers. Coming to the problem statement, that traditional approach is to be assume the base of the building to be fixed for the estimation of the natural period and ignore the influence of soil structure interaction. During the past and recent decades, it is realized that the soil structure interaction effects plays a major important role in determining the behavior of building structures. And then in these studies, the effect of the soil structure interaction may determine the seismic response of structure, and negative to the analysis maybe lead to unconventional design. This is the model I taken for it. Research in this project, reinforced concrete structure which has different types of foundations, varies stories where of soils, different types of soil structures interaction by using the software of SAP 2000. Objectives in this modification factor for a frame made of the reinforcement concrete with soil structure interaction affects the to be fixed base foundation and the awareness of the structure behavior different possibility to get the optimization, which is to structural and human life safety and economic. The methodology is taken from this analysis of structure with natural frequencies, structures with varying storage and dimensions, having different types of soils and having different type of foundations and different types of soils. Comparative of the SSI from parent element analysis by using SAP 2000. These are the analysis data of the soil. In this hard soils, medium soil, soft soils, mainly. These are the foundation details of 5-story, 10-story, 15-story, 20-story. In this, we take a isolated combined mat pile foundations. These are the model we taken from this 3D structure with base, 3D structure with structure, deformed shape, soil structure interaction. This is an analytical work, soil structure interaction. Is to be solid stress. Coming to these graphs, isolated in this isolated footing, there is a first one is solid stress, and there is maximum and minimum stresses, as well as same to be moment of forces needs to be comparison between that, as like as to be combined mat pile foundations, minimum and maximum solid stress. It's a 5-story structure. As simultaneously, we taken a graph of 10-story building and 15-story building, 20-story building also. It's a fixed base. And do an dynamic analysis of 10-story building of isolated combined mat pile foundation. In this soil structure interaction with the dead load graph, it is. These are the main values, frame moments for 5-story, 10-story, 15-story, 20-story. Isolated combined mat pile foundation, minimum and maximum. Coming to the conclusions, RC frame built resting on the soil, which have lower weight of volume, having the highest SSI effect, highest unit weight of lower SSI effect, which occurs in the soil domain and also in the frame structure. Moments occurred in the frame structure can be varied depending upon the soil and foundation system analysis. Soil structure interaction affects the structure more compared to fixed base at the foundation. From the analysis results, it will be a minimum range of 2 to 4 times more than soil structure interaction fixed condition. When varying the foundation type to a particular structures, that a structure are different from one type to another type of foundation in soil, deposit, and frame of structure, having soil structure interaction and fixed condition. For example, to take a 5-story building analysis, a combined footing and
It's okay,
getting the
Sairam.
approximate.
We can understand. Please conclude.
The non-linear model. Sir. Some of the reference I taken from this. Thank you, sir.
Okay, thank you. And this is the final call for last participant, Shyam Prakash. Are you there? Shyam Prakash, Madhuri, Nikita, and Sharik, Muhammad Sharik. Shyam Prakash, Madhuri, Nikita, and Muhammad Sharik. Any one of these 4 can present.
Yes, sir.
Yeah, who is this?
This is Dr. Sarath.
Yeah, Sharat sir, tell me.
Actually, is there any leftover papers are there in the middle? Maybe
Yeah, there is one guy by name Shyam Prakash. He is not responding. Other than him, everything completed, sir.
Okay. I think that paper also others are not available.
Yeah, not available. Correct, sir.
Yes, I think so. I think we may go for wind up of the section.
Yeah, we will conclude, sir. We will conclude.
Yeah, I have some.
Yeah, sir. Tell me.
I have some observations to the others, sir.
Yeah, please, sir. Please continue.
The thing is that whenever we are presenting the PPTs, the content should be very less in the presentation and explanation should be more. It should be followed as 6 by 6, 6 words and 6 lines. But so many others are not explaining. They are keeping so much of data in the PPTs. It's not good. And please follow the time. please follow the time schedules if possible and complete the tasks. And I think our co-chair is also there in our presentations. Hanma sir, Dr. Hanma sir.
Hello, Dr. Hanma sir, welcome.
Welcome, sir. Hanma sir, you are there? I think sir is busy with some other work, maybe.
Yeah. You continue, sir. You continue.
Yeah, and all the presentations are completed peacefully, and it's good presentations, and everybody explained very clearly. It's good, and I thank the support of Surya sir for completing the section peacefully. Thank you, sir. Thank you very much. I
Thank
also
you, sir.
thank other faculty members like Sham sir and Sukishwar sir for staying in the section and following the section, and JD sir also. Thank you, sir. Thank you very much.
So thank you, sir. First of all, I would like to
accepting our invitation.
Thank you, sir. Okay, sir.
Surya, sorry for the comment. Surya, go ahead.
Yeah, thank you, sir. First of all, I would like to thank our co-chair and chair, Dr. B. Sharachandra sir and Dr. Hanuma from VR Siddhartha. Thank you for your insights and thank you for your valuable suggestions, sir. And also, I would like to congratulate all the participants for their successful presentation in this two-day international conference on advanced construction materials. Sham sir, that's all from my end. If you want to speak few words, you can. Otherwise, we'll wind up this session. Anyone from participant want to share any of your views? Okay, Sharchandra sir, nothing much. We will wind up this session, sir. Thank you. Thank you.
Okay, thank you, sir.
Thank you for your support, sir. Yeah.
Thank you, sir.
Thank you all. Yeah, thank you.
Okay, officially now we will wind up the section. Thank you.